today's topic is about Weger's diagram. Let's break this diagram into small bits and pieces to make it simplified. First of all, you should know the cardiac cycle. First there is atrial systole, then there is ventricular systole, then there is ventricular diastole. Atrial systole has three, that is isovolumetric contraction, rapid ejection, then there is slow ejection. Ventricular diastole has got 5. First one is protodiastole, then there is isovolumetric relaxation, then there is rapid filling, then there is slow filling, and then there is atrial filling. First we'll start with pressure volume graph. So first we'll start with ventricular systole. It has isovolumetric contraction. Matlab iso means same, volume is isovolume. See, volume remains same, only pressure increases. See, y-axis is pressure and x-axis is volume. So isovolumetric pressure, volume is same, only there is increase in the pressure. This is isovolumetric contraction. Then there is rapid ejection, then there is slow ejection. This marks the end of the systole. So the volume is end systolic volume. It is around 50 ml. This is protodiastole. Then there is isovolumetric relaxation. Isovolume. Volume is same. Relaxation. Matlab pressure is decreasing. See, pressure decreasing. Volume remaining the same. This is isovolumetric relaxation. Then there is rapid filling, slow filling, and then there is atrial filling. So this is systole. This is diastole. Let's complicate things. So before isovolumetric contraction, there is S1, that is closure of AV valves. At the end of isovolumetric contraction, there is opening of aortic valve. This is rapid ejection, then there is slow ejection. This marks the end of systolic phase, no? So this marks S2. S2 means closure of aortic valves. This is isovolumetric relaxation. At the end of isovolumetric relaxation, then there is opening of AV valves. This marks the basic for the Weger's diagram. So you should be thorough with this diagram. Now coming to ECG and JVP. First ECG. P. This is Q, this is R, and this is S and T. This is P, this is Q, this is R, and this is S and T. From the starting of the P wave to the mid of R wave, this is atrial systole. From R to end of T wave, this is ventricular systole, and then there is ventricular diastole. So let's write atrial systole, then there is ventricular systole, then there is diastole. So next JVP. JVP is, this is A, then this is C, this is X, V and Y. 3 positive waves, A, C, V, 2 negative X and Y waves. So A wave is atrial contraction. So before this, these are the four chambers of the heart: atria, ventricle, right atria, left atria, right ventricle and left ventricle. See, A is atrial contraction, matlab filling of the atria. After filling of the atria and ventricles, after filling of this, let's add at the end of the atrial systole and before the starting of ventricular systole, there is S wave. S wave is closure of, see, before, after the atrial systole, before the isovolumetric contraction, this is S wave, closure of AV valves. Ventricular systole, closure of AV valves, there is small bulge. After the closure, due to this filling, there is bulge of tricuspid into the atrium, which is represented as C wave. Then there is relaxation, and after the end of the systole, there is S2. After the systole, there is S2, and S3 is due to atrial filling, and S4 is because of atrial contraction. This is pathological. See, isovolumetric contraction, rapid ejection, slow ejection, slow ejection. This is systole. And isovolumetric relaxation, aortic valve closes, then mitral valve opens, then the mitral valve opens. Rapid filling, slow filling, rapid filling, venous filling. And then there is some heart sounds. S1 is isovolumetric contraction, S2 is isovolumetric relaxation, S2 before isovolumetric relaxation, S3 is also during S3, you can see here. S1 is during systole, and S2, S3 is diastole, and S4 is again atrial systole, and JVP. S4 correlates with A, and S1 correlates with R and S, and V2S and ECG and Y. I hope this diagram is a bit easy now. Thank you.